We do expect that you already have this software accessible to you if you plan to run the exercises during the course. And if not, like Darius mentioned, you can put something in the chat window, and if needed, we can stop for a bit to go over and show you where to download that. Now, from the standpoint of invoking the product, there is sometimes a dependency on whether you install it just under the solid thinking or like I have it installed under HyperWorks. And what I like to do is, as many of you are aware, I'm sure, there are the ability to pin programs to this bottom taskbar to make it a one-click startup. And that's what I've done here. And if you've never done that before, just a very brief tour is you just have to find the code inside of your start menu. Here I have Windows 10. My installation is under HyperWorks, but yours might look more like under solid thinking like this. But whichever one you have, all you basically have to do is go down to the actual application. So for example, in this case, if I was to go to Compose, and inside the start menu, you do a right mouse click, and you don't select pin to start. That's a different way to do it. Under more, you'll see pin to taskbar. Of course, mine's already pinned, so I see the opposite choice. But you should see then the pin to taskbar. Once you do that one time, you'll see this little pyramid, this yellow and gray pyramid show up, and that's how we're going to launch the product from here on. Of course, you can launch it direct through the start menu, but this just makes it easier from there on. So in a bit, when we get to it, we'll launch the product, and you're going to get a look at it there. Last part of the big picture is that when you do download the material that Darius pointed you to in the chat window, and you unzip it, you will see a structure similar to what you see here. There's going to be a small group of demo files. There will be a manual. This is a manual that is what contains the exercises, and when you open it, it looks something like this. We're going to be tapping into that during the class. There'll be a group of model files, which have some subdirectories corresponding to the chapter where either some files are needed for input or something along those lines if you need the files. Then there's a PowerPoint in the native form as well as a PDF form. And those you won't so much need live because I'll be projecting that information, but if you get back to them later, you'll be able to do that. So now you know how to invoke the product, you know how to find the various files that we're going to utilize, and what I'm going to do here is start up with this very first PPT. It's actually a very brief overview, so it's kind of called Chapter 0. When I get into the software a little later, I'm actually going to keep the PowerPoint in kind of a non-projection mode. I can hear, Darius, I don't know if that's your keyboard. I can hear a keyboard.
It was, sorry. Yeah, it was me.
Yeah.
It's fine.
So you will be able to bring up the software to apply the exercises, but because I'm going to toggle back and forth between the Compose interface and the PowerPoint kind of very, very often. I like to kind of show the command and then demo it. I'm going to leave it in this edit mode, otherwise I'd have to be escaping out just too many times. So with that, let's get into the picture of what this is and go from there. There are actually 3 products that were released in the past year, are offered by Altair, again under the Solid Thinking brand, and they all apply to different parts of the math and 1D domain. So clearly we're going to talk about and only about Compose today, but just for your awareness, there is also a pair of 1D block diagram building tools. One of them is called Activate, and that's focused on the simulation space. This again competes with codes like Simulink and also has legacy support for Simulink files. And it's a 1D, very, very aesthetically nicely laid out block diagram building environment, very strong for co-simulation and FMI, FMU-based co-simulation, as well as direct co-sim with a various set of tools. Then the other, which is called Embed, is also a 1D block diagram environment, but specifically for ending up with hardware in the loop, where you take your controller that you've constructed and you download it to a, for example, a Texas Instruments chip to perform motor control. just a brief overview of the big picture. So let's go into Compose from here on in the rest of our time. So what is solid thinking Compose? You can describe it with a few different points. It's basically a very high-end matrix-based calculation tool. It is also implicitly an all-out programming language that you can use for, and it's interpreted programming language, so there's no compiling needed. And it is something you can use to open files, import data, run any sort of script that you create, math type processing, whatever you would like, and then even take and export that data back out to files, or like the next line shows, you can take various data that you have in your memory space and create all kinds of different plots live right there in the interface. It's also known as an IDE, or integrated debug environment, so that for actually the Compose language, as well as for the TCL language and the Python language, you can do things like set up breakpoints and walk through different functions as you exercise a script to effectively look at the memory space, modify or overload values, and perform debugging. One unique capability that you see in this tool is that many of you who know Altair know that we have an entire suite of products in the 3D domain, so multi-body dynamics, structures of all kinds, fluid dynamics, electromagnetics, high and low frequency. We have all these different codes, and we have a lot of integration between Compose and various parts of those other codes. And that's unique to Altair because we have both the 3D solution set and the 1D solution set. And then, as mentioned, it is very MATLAB and Octave compatible, and it will. It's actually natively built to support the same language. So it's not even something where you're running a translator. Literally, the language is consistent, and you'll see that as we dig into the commands and get past the exercises here. So that's a very brief intro at the kind of overall product level and what it is. No exercise to do there. We're just going to roll right into chapter 1, where we start to get into a little bit more meat of the product.
John?
So yes, sir?
Is it all right if I interrupt you, and I'll just show a couple individuals mentioned, wanting to get access to the student edition.
Yes.
So, okay.
Absolutely.
Yep. So just give me a second here. I'll change over to myself. And so, fortunately, it's if you use our other tools, whether it be HyperWorks or Inspire, those are tools we've had for a while, and they're all centralized on the one site that I showed you for the academic site. Solid Thinking new products, Compose, Activate, and Embed are again relatively new, and they yet haven't been made available on the academic site, but it's under the traditional Solid Thinking site. So if I just actually just, let's just walk through here from the beginning. And so if I go into the www.solidthinking.com site, and if you go to the try by option, you'll see there's a student and educator button. And when you click on that, you just say you would like to get an academic license, and basically you fill out this information here. And unfortunately, these are all manually processed. We try to validate the school, the email address, make sure everything is kosher, because the version here is again can be used for commercial work. So we try to make sure that everything is passes, and so usually it's one business day for a request to come in. So if you don't have it right now, watch what's going on here. Fortunately, I know some of the stuff does build on itself, but the first, you should be able to jump in pretty quickly tomorrow once you get everything ready to go. So you'll just fill out the information here, and make sure you use your .edu email. If you don't have a .edu email, it will be denied. So Gmail, Yahoo, Hotmail, they will be denied. So use your .edu email address in here, please. So that's how to get access to it. once you know where it is, it is relatively easy at that point. So, all right, John, I'm going to switch over back to you.
Okay, sounds good. Okay, thanks, Darius. And yeah, that's important for anybody who has not installed this or any of the other EDU software to know how to get there. So, picking up on really the first main chapter of Compose, what we're going to do is walk through kind of just the general aspects of what this user environment looks like. And I'm going to do this through slides, and then as we get into the commands, I will start to bring up Compose and jump back and forth a little bit between that. So in the overall class agenda, now we are not necessarily going to have time to get through everything in the 6 hours that we have in this course, but one of the really nice things about this product, even compared to others inside the suite, is that it's very straightforward to self-teach. So that, you know, even if we can only get through, say, chapter 8, for example, the ability to take the training material and then just continue on, even on your own time, it's very straightforward because the help is there, and it's kind of like once you understand the general gist of what the thing is, it's straightforward to take existing material like this. So we'll get as far as we can get, but you're free to continue on for anything that we might not cover. So the idea is that throughout the 6 hours, or 5.5 now, we're going to go through the general usage and environment, which is what we're going to focus on in this chapter. Then we'll get into general functions and data types, on into math and curve fitting, into the heart of how data is held, which is in the matrices. Then we'll go into the plotting capability and how you can manipulate the plotting attributes, either interactively or through using something called handles, which allows you to programmatically control the plotting. We'll just briefly touch on a few categories of higher level functions, just so you're aware of what they are, what they exist, how to find them, and then from there it just becomes a little bit of a reference manual thing if you were to need to use those. Then we'll get into a little bit programmatic aspects in chapter 7 with expressions and logic and looping, and also for functions and how to use the debug environment. And we'll start to wrap up doing some analysis using strings and file management, opening, closing files, writing to files, reading from files, and then with a brief lesson, and finish with a brief lesson on how to even use this environment to create your own user interface that you then use as a tool from there forward. For anybody in the class who is already like a power user of MATLAB, most of this will be already known depending on your level of knowledge of MATLAB, except for when we get into things like the interaction in chapter 9, where we have the interaction and integration between Compose and other HyperWorks products, because that's something that Octave and MATLAB don't do. But keep that in mind, and then follow along to the extent that it makes sense given your knowledge base. So let's dig into the general usage and user environment. We already talked a little bit about the start menu, that you can run the code in its traditional form with the full UI, but you can also bring it up in just a console mode where you have nothing but the math engine brain that you type commands. That's almost kind of old school style, back before there was the overall UIs that we have now in the product. So when you start the code up, which I will do here by clicking one time on that pyramid, you get into what by default is called the authoring environment. And the authoring environment is basically the opposite of the debug environment. So it'll be a little later that we go into some of the debug capabilities. But the authoring environment is where you basically build up your scripts in the editor, and you can also have immediate interaction with the memory space as well. So let's take a brief look in the slides of what some of this interface looks like. So any of you online who may be familiar with Inspire, both Inspire as well as Compose and Activate and a few other smaller codes are leveraging Altair's new look and feel interface. So kind of a next generation beyond the traditional look that you might have seen in a hypermesh or a hyperview motion view, for example. And so this environment has your things that you're used to seeing, like a file menu, although it's maybe a bit reduced compared to some of the traditional codes in order to be compact and easy to use as possible. There are ribbons, and the ribbons themselves are actually, in some cases, position dependent, mouse position dependent. So there might be parts of the ribbon that, on certain products that use this environment, that are actually a function of exactly where the mouse is on that ribbon item. So you have control of many of the main parameters through this, this main ribbon or this toolbar, primary toolbar. Now, there's a lot of different areas, and you have the choice of turning them on or off. They're just a simple toggle through that view menu. There's the project browser, which is the big picture of, well, how many different plots have you built? You know, how many figures have you created? What are the different blocks in your project? There's the property editor, which is actually used a little less in this product compared to the others that leverage this environment. So it's there, but I will not be using that too much in this. Whereas codes like Activate and Inspire, the property editor is a very key piece of the daily usage. Down in the bottom, you have this session information where you have actually two sub-tabs. There's a command history, which reflects the log of anything you've typed interactively. That also persists. So even if I close the app and open it back up, I'll see a command history going back for pretty much to when I installed it, unless I've gone in and deleted some of that history. Then there's the variable browser, which reflects what is currently in the memory space. What are the variables? What are the values? What type are those variables? And if they have a particular context. That's down the left. Then you have, in the center is your main working area. You have your editor window that provides the script building environment. This is the one that, okay, I'm in an authoring mode, but when I switch over to a debug mode, you know, it's this environment that the debug mode tends to act on. And this is where you can effectively build these scripts. And when you run them, which is one of the buttons up where there's the stop run, what basically happens is the script is run from the beginning on down through. And then if you want to do things like run it from the middle and stop it, that's where you get into the debug mode. But just in a regular authoring mode, you work on the script and you hit run and you see how it works. And it will either produce the plots and the output that you're looking for, or if you have some sort of error, it will echo that back to you. That's your main editing window. Underneath that is the command window, where anything you type in and hit enter immediately will react to that. And you can use these interactively. So you might run a script, which is going to load up the memory space like you kind of see on the bottom left where there's the variable browser. And then you might do some things interactively, take a look at the values or manipulate that data. So the script that's running and the interactive window are reflective of one and the same memory space that's live at that time. On the right, there's a couple of nice browsers. The top one is the file browser. This is great because you can just drag and drop any of the files. Now, the extension on the Compose files is called OML, stands for Open Matrix Language. So anytime we're talking about bringing in one of these files, like you kind of can see up back in that editor window where you see the general Euler spiral.oml. And so you'll see the file name there, and you literally can just drag that from the file tree over, and you can have as many of them that you pull over as you want. So there's a lot of nice modern aesthetic as well as functional things like drag drop all built into this modern UI layout. So over on the right then is the file browser, and that file browser also acts as your present working directory. So when we get into the commands later that can interact with your system, like typing a directory to list the files, it's going to do it as a function of the currently working directory you have selected up in that file browser. And then finally, there's this thing called the library browser, which is effectively a shortcut access to all of the about 579 built-in commands that come in with Compose. Now, this is an important point. as far as access to the commands. We ship the product with everything in it, at least everything that's included in the EDU or everything that's included in the full commercial version. It's just there. You don't have to worry about going in and trying to grab a different toolbox or another toolbox. We take the big list, and I mean, we categorize them, as you can see in the bottom right-hand tree. You got to categorize them to keep them, you know, from being too difficult to manage. But from a kind of a installation management standpoint, you don't have to be worried about the concept of toolboxes. Everything is just there, built in. So that's a brief layout of the interface. There's a zoom in on a few things here, like the command history window I talked about, the variable browser. I'm not going to spend a lot of time on the text because I had described that. Now, the next thing I'm going to show are maybe some just general concepts to know going into using the code, even before we get into commands and things like that. With these, I'll kind of demo them a little bit. So let's start out with a few GUI tips and tricks. One of them is that if you have a particular command that is in your editor or in your command window, you can click on that and go to the help directly, or you can click on F1, and this will provide you with, well, various context menu options, but the handy one is jumping into help. So let's start out and go over here and say something like, you know, length, and notice how it gives a color once I complete a command, and that becomes kind of a recognition that you're working with one of the built-in commands. And so what I can do on this is highlight this and do a right mouse click and click F1 and immediately get the full help tree, which you can see over here in the reference guide. You have the OML reference guide, you have all these different commands, and then in this case it went to where length lives, which is under elementary math commands. There's a whole big long list there, and it gets into the help description for that particular command. So that can be done whether it is in there or even if it's in the editor window. Same thing. You can jump to help directly and it'll get you there. Another way to get to help is to be able to go under File, and then here's the help tree itself. And you can walk over and go into the tutorials or into the general help and navigate through that. And that's important because I mentioned about how this code is relatively easy to self-teach, and one of the key enablers for that is to just know how to quickly get to the help section. So here's where you can just access the help, as I had mentioned there. There is an autocomplete feature. Now, there is the ability to control if you want to have this show up immediately or have it with a small delay or not show up at all. So that can be controlled in the preferences. But this is real handy. If we do something like mentioned there, if I do get type, you can see as you complete the string, you know, when you start out, there's going to be lots of choices, right, when you only have the first letter or two. And then as you complete the string, it goes to the, you know, whatever is remaining that starts with that string value. And you can hit enter, and it'll complete that, or you can just continue to type until you're done constructing the command that you wanted. Now, I had mentioned about how you can modify some of that with the preferences. I just want to show you where those are at the big picture. So under File menu, down here, there's this Preferences. I'm not going to go through what all these settings are because you can play with those and look in the documentation, but you can control a lot of things on the product through that area. Again, that's File, Preferences. So I'm trying to give you kind of the big picture so that you'll, after we kind of get through a bunch of things in these 3 days, you'll easily be able to run with it from there. Even if you're not an expert, of course, by that time, you'll have the basis to know how to become an expert. Oops. Okay, so on to a few more tidbits. If you're brand new to an environment like this, the general way that it works is that if you do not put a semicolon, the result of the command will be echoed to the screen. And if you put a semicolon, then it suppresses that. So let me go here and just say something like A equals 1. If I don't use a semicolon, it echoes it back. If I do, it keeps that suppressed. And that's important because when you get into building up big long scripts, the last thing you want to have if you do something like A equals 2, whoops, B equals 3, and C equals 4 is every time you run that you may not want all that echoed, especially if you start getting into the dozens or even hundreds of lines involved in a script and functions that are calling other functions and things like that. So a pretty normal programming habit in this environment is to end everything with a semicolon unless you have a reason that you don't want to. And that helps it so that it does its math and its number crunching, but it doesn't echo back when you don't want it to echo back. So that's just another little tidbit. There's also the ability to recall previous commands using the up arrow. So as I continue to type in the up arrow, it's capturing the history. I can go back down, I can go up. And when I get to the one I want, I can always just hit enter and it will take its effect. So keep in mind, that's actually really handy when you're building up when you're doing interactive and you're building up a little bit of a script. You can also grab one of these, like if I went up here and I found the one I wanted, maybe it's this guy, you can also just take and Control-C that and Control-V it too, back into the editor window if you need to. So some little tips and tricks on that. A couple other things that you kind of just need to know once and then you know forever. There is a case sensitivity, which means capital A. So let me clear out my memory space. You'll learn about those commands in a second. But A equals 1 and capital A equals 2. So A and capital A. They're as different as X and Y or Q and Z. So there is case sensitivity, and that means I could make a variable name like Apple equals 4, and I can make a variable name with a capital P, PLE equals 5. Those are two different variables. So case sensitivity gives you a lot of ability to make unique bar names. You can use an underscore as the beginning of a variable, but only the underscore is really the only special character you can use as the beginning. And sometimes people like to use that as a modeling or a scripting convention. Maybe it's internal variables only or something that variables you're not supposed to touch or whatever you might use it for. But every other special character is you can't use to start. This is a one-based system. It is not a zero index system. So if you're used to programming in C, then you're going to have to do a little bit of a mindset. If you're bouncing around between different codes, this is something obviously you got to think about. But obviously, you get into matrices. So I might say A1 equals 5. There is no A0. I can't assign any zeroth element. So it's a one-based system. That actually, from a standpoint of the ease of use of the language, that actually makes it pretty straightforward. A little bit easier than dealing with C, but there are advantages in the world where you do compiling. There are some nice advantages to C and a zero-based system, but just keep in mind that it's a one-based index for everything matrix. If I get into just a sneak preview of a matrix for a second, I might say A11. Let's do this. Let me make A equals rand 2, 3. We'll get into details of that later, but you can see here that I have a 2 by 3, and if I wanted to access the first one, it's 1, 1. So in regards to columns, rows and columns, it's a one-based system, which would make sense. There is the ability to encrypt a file. This is just to make you aware of it. It's actually a relatively new feature that has come out. It's probably not too needed in the academia, but when you get out there in the real commercial world, and there's a lot of intellectual property that gets embedded into various functions and algorithms, there are times that you may want a customer or a supplier to be able to run the script that you've created, but not necessarily have access to the source code that you've written. So there's a handy little feature called Encrypt File, and it turns the OMC file into this unreadable, it turns the OML file into this unreadable OMC file, and that allows you to then run that file, and it'll run it, and it'll behave exactly the same. So just keep in mind that there's a nice little encryption file there. So what we'll do here is, been talking for a little while, I'm going to turn it over to a first exercise. Here's how you find that exercise. You go over to the directory, the material that you downloaded. You find the manual subdirectory. You open up the manual subdirectory and you should see something like this, the 2017.2 or whatever version you're running. Even if you're running an older version, 99% of everything we show in these 3 days will run in any version 2017 or later, with just maybe a couple small exceptions. So the first exercise, what we're going to do is scroll down. You got to go past this. Now you'll see the title of it over on page 5, but we also do our manuals so that they would print out and kind of look nice when they're printed out and put in a book. And because of that, you'll see a little bit of white space between that little title page. You got to jump down a couple pages. This is how it is for all the exercises. And the actual meat starts on exercise 7. I'm going to have you skip the very last step in this, is an exercise to run in batch. I'm going to have you skip that for now, but everything else you're going to do is interactive, and you're basically just going to get introduced to this environment to see the things yourself, play with the various areas that we just played with, and just walk through the commands. They're very step by step, and if you need them under the models directory, there's this 1A, which we will need them, and when you take, and for example, you go over to the file browser and you pick, you go down to that area. Let's say I go down to training, compose. Let's see, which one do I end up working with here? The actual compose 2017.2. So go back over here and take this guy. Now if I pick, say, model files working, and I hit OK, now that becomes my working directory, and I can just take files. Let me stretch this over. I can just drag them over here like this. Oh, another point. I didn't have it on the slides, but if you do it inside of the editor window, if you press Control and you roll your mouse wheel, you can zoom in, and that can help a lot for a lot of this little textual type stuff. So again, it's Control, roll the mouse wheel up or down will give you the ability to zoom in the editor window. That's the main window where that applies. So keep that in mind. And when you do that, you can pull these exercises over, and there's this Start Run button, which is where you can actually initiate the script. It will run top down, and you'll see some response. In many cases, it's going to build up some plots and the like for you. Yes, I did get a zoom into the, there's a lagged zoom for the interactive part, the command window as well. So what we'll do is it's about 4:15. I'll give you 15 minutes until 4:30. If you can't finish, no big deal. This is very straightforward to come back to, later tonight or whatever, to top off anything. But we do want to cover a certain amount by the end. And so begin on the page 7 of the manual and walk through everything except when you get way down here to step 16, I believe it is. There's a step 16 that says run, compose, in batch mode. Just skip that for now. You can do that later if you need to. Oops. And go ahead and get started. I will go on mute, and if I see questions, I'll answer them in typing if it makes sense, verbally if it looks like something that everybody should hear, and I will be back on at 4:30, and we'll pick up with chapter 2 and start to get into some of the actual how to do the commands for this.
Okay, great. Thank you, John. So if anybody has a question, please type it in the window so John can see it. I'm going to stop the recording just so there's not a lot of dead space or noise on here. So, and start it if there's a good question being asked.
And I will step away for 20 seconds for a water refill, but I'll be back here. And let's start to dig into the heart of what makes the product usable, which is the commands. So we'll give a second for, there we go, for the screen to come up. and let's dig into some of the general functions. So the product comes with many, many functions included. Of course, you can always build your own, which is a section we'll get to a little bit later. But we're going to go into what some of these more general functions are, kind of the more broad ones, and then a little bit of an introduction to some of the data types that you can make variables inside of Compose. So there's, as I mentioned, there's actually on the order of 579 built-in commands. And these can be divided into some of the following categories: those that are just general, those that interact directly with your system, your operating system. You have all the different operators, commands that kind of act as math operators, as well as lots and lots of functions that perform some sort of operation, math operation. Then you get into things to control the programmatic aspects, ifs and while loops and for loops and things such as that, and the various commands that go with summing up expressions, all the different plotting commands, and like I mentioned, the file IO and the CAE reader commands. The CAE reader commands are those that are an example of integration between Compose and other HyperWorks products, specifically pulling data in from established file formats, Altair formats and third-party formats. So starting off, there's a general command that will give you an alphabetical flat list of what commands are in the build that you have. This can actually come in handy if you move from like one version to the next and you want to try to kind of capture what the difference is. You could get the func list from the older version, the func list from the new one, and then do like a graphical diff on them. But it basically works like this. If I can find my mouse. Let me first of all do a clear of the, oops, and zoom. So interesting little zoom lag on that command window. So if I clear this up and I type func list, there we go, and back to the size I want, you can see where it's just a big long flat list. Obviously, if you want them categorized, that's where you go into the help, or you pick one of them and do the F1 and get the help like I showed. But this is a quick way to see, hey, I wonder if this particular command is in here. If there's a command that you know about, you can always just type it in, and if it colors up like the purple color, then you know it recognizes it. If it's something that you are wondering, okay, there's another code that has a certain command, does this one have it? You can look in, of course, you can look in the help, you can look in the func list, but you can also just type the command, and if it doesn't turn pink, it means it's not recognizing it, which means that command's not supported. So it's a little utility way to use that. There's what we call the 3 C's. If you're not familiar with this programming environment at all, there are 3 C commands that it's really good to use at the beginning of every script, and it's effectively the clearing out. So the clear command basically erases a value from memory. If you do a clear all, it's a complete clearing of memory. If you do a clear of a particular variable, it'll just clear that variable, and it's really that easy. So if I go here and say, let me, whoops, missed my A. You can just see how that command window went empty. So if I say A equals 1, you can see in the command, in the variable browser, sorry, that the value of A there, that it exists. I can echo it. Now if I do a clear, A is gone. It completely wipes it as if it didn't exist. The second C command is the CLC. That's the one to clear out the display area of the command window. Used a lot interactively. That's CLC. And then the close, which is to close those windows that have plots on them. And in this case, I'd have to have a plot to make this scene. And if I do a close, I can close the particular figure that you can see as figure 1, or I can do a close all, and it takes that whole figure page off. So what you tend to see is it's a good idea to start all of your scripts with some form of combination of clear all, close all, CLC, and it kind of gets it back to as if you had just invoked it. And the reason you want to do something like that, the CLC is for the aesthetic purpose, but the others is, if you have a script where you've generated data, and then you run that script again, and somewhere in there you have, like A equals A plus 1, you're gonna get the effects of the previous results of the script running affecting the next iteration of running your script, and that's usually not a good thing. And by having a clear all, you're always assured that as the script begins, it flushes the memory space open. And then CLC is just good to make sure that CLC is good, because if there's issues with your script, it's going to echo information back to you. And if you have the screen cleared before it does that, then those are nice and clean. If it's all a bunch of legacy stuff from previous runs that are echoing there, then you might confuse, like, well, was that from the last run try or was that from the current run try? So always start out the scripts with these. Percents are the denoters of comments. Anything where you put a percent, anywhere you put a percent, everything to the right of that percent is going to be ignored. You can do a mix of commands as long as it's in the proper order. I can say equals 1 and percent, then do a percent, and it's totally fine. But if once I do a percent, everything after that in that, whoops, there's the arrow, that will be ignored. So if I say B is 2 up in here, it's going to ignore it. There's no B because I have a percent here that's telling it ignore everything beyond that. So the 3 C's, always started out with that. Clear, close all, CLC. That's a good order to do them with. Another general are who and whose. Now these aren't maybe as needed as much as back in the day when there were no interactive GUIs, where you were just running a console, which is how some of these codes started back in the day. And then you'd want to know what was in your memory space. So you can do a who or a whose, and it echoes what's in your memory space. Nowadays, we have this variable browser, because most of the time you're going to be running and developing the scripts through this environment. Well, you can just look right in your variable browser. So the who and the whose, they're old, they've been there, but they maybe aren't as needed quite as much. There's date command, which echoes, we do a CLC, and that echoes the date. Now, the nice thing about this is we haven't covered matrices yet, but let me give a little sneak preview that everything that gets stored in memory space, in one way or another, it's being held in a matrix. So in this case, what's actually happening is it's creating a matrix with characters in it, and it's a 1 by whatever that is, 8 or 9 different characters, 11 of them. And when I do the date command, then, well, let me do this. Let me say A equals date. So now A is that value. Now A1 is going to be 1, A2 is going to be 7, A3 is going to be that dash. So it actually comes back, whenever you store information, it comes back and it stores it as a matrix. In this case, it's a 1 by 11, 1 row by 11 column matrix, because it's always RC. Whenever you refer to matrices, which we get much into later, it's row count and then column count. So that's just a utility there. There's a neat one that if you have a particular script and you wonder how much time on the wall clock has been elapsed, you can do this TicToc. So I could put it inside of the script, for example. I could put a tick up in here. So I make sure not to save over this. Farther down in my command area, I can do toc. And then when I run this, I can see that it took it a very small amount of time to process the steps between the tick and the toc. So that's a neat thing to kind of do some timing assessment. Clock gives you the day, but it stores it as a vector with 6 entries: year, month, day, hour, minute, and second. So it's a 24-hour clock. And again, that stores this as a matrix. So if I say A equals clock, here's A, and in this case, there's actually numbers. So A1 is 2017, A2 is 10, A3 is So you can actually take these results from functions and then go on and do stuff with them downstream because it stores that data in these convenient forms. So in this case, it comes with a 1x6 matrix of data, numerical values. Pause is something where you can control the environment to just wait a few seconds before it continues on with the script. The place that I found this familiar is, we do a lot of modeling here, and there may be times where I'm running a script and I'm going to, inside the script, I'm going to launch a solver. And I know that solver is going to take 5, 6, 7 seconds to run. And then maybe farther downstream in my script, I have some post-processing commands that are going to open the files from that run. Well, I need to make sure that run is finished, and it's an external process. So what I can do is say, well, experience shows me that this run takes 3 or 4 seconds, so I'm going to have compose pause for 5 seconds. That way my downstream code is definitely going to be working on the the most latest complete results file. So that's one place that you might use the pause command. And literally, if you use it interactively, and I say pause for 5, it's just going to take control away from me. Oops. Yeah, I can't do anything right now. It won't respect my click, and then it comes back and gives control back to me after 5 seconds. Okay, and then you get into some of the things that affect the system commands. So the important one here is path, and when you get into functions later, it's important because when we do functions, in order for the code to know that you've written a function in a file, it needs to be in the path. And the path commands allows you to basically look at what the current path is if you don't give it any arguments, or you can actually update the path if you give it arguments. So here, if I look and I just see, well, what is the path as the product is launched? It knows to look into these 3 directories, the one that ends in _macros, the one that ends in CAE toolbox, the one that ends in OML. And that right now is being set by a couple of things I've done previous to even launching the code. We'll talk about that. There is a startup script. So this is very powerful, actually. I'll just get to it now while I'm thinking of it. There is a startup script that the code will hit when it automatically when you invoke the product, and that script is a normal open script. You can do whatever you want. You don't really need to do CLC and clear and all that because it's only going to get hit when the product invokes. But it's a good place to set some paths if there's always a set of paths that you want the product to know about. And the place that is basically down in your user home. So if I go over here to users, JSQ, and I go down into Altair, compose 2017.2, there is a solid thinking compose _ startup.oml. So again, this is in whatever your home directory is under .altair, under the compose version that you're using. And you can go in and you can edit this. And here's where I had put in a couple things, and one of them was this add path command to append to the existing path. And I put in some other things just to kind of test out this. So keep that in mind that there is a startup OML file, and I can come in maybe there's a bunch of variables that you want to set for your project that you just want those in memory space when the product turns control back over to you. The startup file is very handy for that. But here we're talking in the context of paths. So when I type the path command, I can see what the path is. I can also overload the path and create a new one if I want to. And again, very handy when it comes to having the product know where files are, because it's going to search the path from top down when it's looking for some file that you've asked for. Add path is just what you saw in that startup script. It retains the existing paths and then adds another one to it. So if I do that here, add path :junc2, we like to use /. So now if I do path, now I have this. It prepended it with the new path that I added to it, which you can guess what the next one is, which is RM path. And that's the ability to cherry pick certain paths that the product knows about. So we'll take that one back out. And I'm back to a nice path that I started with. Present working directory is the one that the code basically, if you're going to save a file out by default, if you are going to type a command for a file, it's all going to do the present working directory. And as I mentioned, it's actually echoed up here in the file browser. And by the way, I had mentioned it's under you can turn all those different windows on and off. I mentioned it verbally, but I didn't show you. You can under the view menu here. So let me clear this and basically do present working directory. And you can see that it's going all the way down to this directory here, which is here. And if I take a second and I step up one directory, and I do pwd, now you see it went up one. So it's exactly in sync at all times with the file browser current directory there. Okay, let's keep going. About halfway through these slides, I want to give you, finish by about quarter after so that you can take 15 minutes to do the exercise. So we're still talking about system commands. So there's the dir, which is basically emulating as if you were in a command shell window. You type directory and it shows the dot, and all the files that are in it. So that's pretty straightforward, pretty easy so far. You can affect the directory that you currently are in. So I can do a change working directory, and I do cd. If I do a cd dot, I go up one. Now here's what I want you to watch. Notice that file browser area again. So if I do a cd dot again, it steps up and then it updates. So if I do, I just went back down it, but now let me do pwd. You can see that it's there. Now, so there's a perfect synchronization, as you can see. And now if I do pwd, it's down there. So cd lets you change the present working directory. Again, not all too difficult so far. Now, got to be a little careful as you move on, because some of these next commands can permanently affect your, your disk setup, your file setup in your operating system, because these commands are basically emulating as if you were in a DOS command window. So if I do make dir here, so let me, if we look at where we are now, we're in the model files, and you can see up in the top right the list of directories. So if I do a make dir and I say hello dir, I just built that. That's on my disk now. I can go back up here and I have to dig for it a little bit, but it is there. Let's go down here to inside model. There it is, hello dir. Okay, so there's the first command that actually has a permanent effect. And of course you can do rmdir as long as you're in the proper context. I just remove that directory. So you have make directory, remove directory. You can grab environment variables. Most of you are probably familiar, already being in school, that there's the various operating system level variables that you can set that different codes might grab, and here you can do that as well. So you can get env, and there's an infamous one of temp that's always floating around. You can set environment variables, but keep in mind in this case, if you're setting the environment variable, you're setting it temporarily as a function of the session. So if I close this out and I open it back up, that environment variable is going to be lost. So it's, in this case, set env is not, it's not emulating me going out to the file browser down to the computer and setting environment variables. It's really with regards to the active session. Whereas getenv is, getenv is grabbing, just grabbing the ones that are there from the operating system. So that's setenv and getenv. Now you have a system command, which is really just a general command saying whatever string that you're going to put inside of it, it's going to pass it out to the system command. So I can say system, dir, and I get it's exactly the same as if I was in the command window here like this. Okay. The thing you have to be careful with, again, is if you're going to do a system command, whatever you put in those strings, in those single quotes, is going to happen. So be careful about ever doing anything like RM star, right? I can fry your whole disk. So you do have the power of tapping into the system, but be careful with that power. So moving over then for the second half of these slides, which is the data types, kind of from simple up through the most complex, there are data can be held as strings, which is actually a matrix of characters, ASCII characters. All values, all numerical values are held as doubles. So let's talk about this for a second, because when you talk about numerical values, there's the display of what they look like to you, and there's also separately to that how they're held in memory, like the level of precision. So I can answer the second one very easy. Every number is held as a double. Even if it is going to appear as an integer, it's still held as a 8-byte double. Now, how it appears is where Compose actually gets a little bit smart. If you don't specify any formatter, which we'll get down later in strings and stuff on day 3, we'll talk about the formatting. But if you just kind of have the number echo back, it actually remembers when you specified the number, did you specify it as an integer or a real or a float or E notation. So if we go back here and look at that a little bit, notice when I typed a equals 1, it echoed back 1. It didn't echo back 1.00000. If I say a equals 1.0, in this case, it recognizes that, hey, that's basically an integer. If I put a equals 1.002, then it says, okay, there's obviously a precision level you want me to echo back to that. If I say b equals 5e to the 9, then it says, well, okay, yeah, that's an integer, but it's going to come back and echo it as 5e to the 9. C equals negative 2.7e to the 4. It says, well, I'm going to be a little bit smarter there. That's a small enough magnitude that I'm going to turn it over to a more of a regular numerical display, non-scientific notation display. So from a display standpoint, it kind of has some smarts built into it. Later, when you get into the real world, where you may echo something where you actually care about the literal precision that it returns back to the user or into a file, well, there that gets into the whole file I/O and format specification. But just as far as kind of generic, hitting numbers and what do they echo back, it tries to know, recognize what you want to see. But underneath, everything is held as 8-bit byte values. Boolean is just the true-false. The thing to note about the Boolean is that it is, well, we're going to go into each one. There's an interesting thing about how it displays the status of the Booleans. Then you get into complex numbers. And what's nice about the complex numbers is you can have entire matrices of complex numbers, and there's a lot of built-in commands that work nicely on the real imaginary type complex numbers. Then you get into the heart of how so many things are held, which is the matrices. And that's row by column. It can be row by column of numbers. It can be row by column of Booleans, complex numbers, you name it. And it can be, by the way, more than 2 dimensions. In some cases, you can actually store multiple dimensions, and it will return. You can go in and grab a slice, let's say, of a 3-dimensional matrix, and a slice of a 3D matrix is a 2D matrix. So there's neat capability like that. And then a couple of unique cases. There are cells, which is basically a matrix of entities where each entity can be its own type. So if I have a normal matrix, and I have 5 rows by 3 columns, they're either all going to be numbers, or they're all going to be Booleans, or they're all going to be ASCII characters. But a cell, if I have a 3 by 5 cell, I can have one member be a Boolean, another member be a matrix, another member be a string. So a cell allows you to mix and match and store data in a mix and match. And then finally, the structures are like name, value, pair, hierarchical type objects. You'll see each of those. Let's talk into each of them deeper so we can get you set up for the exercise here. So a string is an array of 1 or more characters. Compose provides multiple methods to store and retrieve data from a string. So single quotes are basically what's used to store the values. And I can say display a string, or I can store a string. So let's go over here. Let's do clear all, close all, get everything back to normal. And let me even get out these. So we're really basically to the equivalent of a fresh thing. By the way, if you ever want to open a new one, it's very straightforward. File new, and then compose file. So I'm back to equivalent as if I just launched the product. So I want to store a couple strings. This is the single quote, so I can say, hey, this is a string. Notice it echoes it back because I didn't put the colon, semicolon. If I put the semicolon, it doesn't. There are going to be a lot of tools that you can see later on in the future chapter with the strings. You can display strings, and then when we get into them, there's so much you can do with them. There's the entire, half a chapter at the end of the course. But just as a brief intro, what this is really doing in the case of A is it's storing a vector of characters. I mentioned that before. So A6 is an I, which is the beginning of the I for the is. And so even in itself, it's still weighed underneath. It's a matrix. It's a matrix holding an array of characters. In this case, it's going to be a 1 by. You can, this is touching a little bit into some of what you can do with a matrix, but you can, show various ranges. So if I go back here with my A, and I say I want to see for A from 2 to, hang on, I was syntax blank there for a second. Yeah, sorry, I don't know why I was thinking that way. So if I do like a it's because it's a row column, so say 1 to 6, then I'm going to see this space I. So you can go in and cherry pick pieces of matrices by giving this range, this colon as a range type thing. And you'll see more of that when we get into even the natural matrices. But one place it's applied here is in the strings. So there is a neat little built-in command. If you ever want to know the length of a vector, there's the length command. And I'm not sure why that didn't turn color purple there, but basically you get the length. It's just the column amount for a row column, a 1 by row column. All right, so there's a lot of times where strings are the output of a function, like when you saw me do the get env, and it came in with a path. Sorry, in that case it was the temp environment variable happened to be a path. PWD was a path. So those things were always echoing back strings, and so they can be treated just like any other string. We'll get much deeper into chapter 8 on that. But, so let's keep going on. So a double, I already touched on that a little bit. I didn't show you that, if you store a whole matrix, let's say B equals random of a 5 by 6 matrix. So those are all doubles. In this case, because I used the rand function, they're between 0 and 1. But just a bunch of numbers, 5 rows by 6 columns. Okay, complex. One of the things that is real nice in this environment is how easy it is to work with complex numbers. And again, it comes back to recognizing what it is you wanted to see. So if I say 1.8 minus 9i, it knows it's a complex number. Or I can say b equals negative I. It immediately knows it's a complex number, so it echoes back the full complex number value. You'll see later lots of functions, if you that are built in for the complex numbers. And I just hit mag. I'm not sure why I did that one, but they'll get into, let's say, square root. That gets real funky because that's a complex number. The real, imaginary part, all in regards to playing around with these. And you can even do the storage of multiple ones in a matrix, right? So I could say A equals 1 plus 2i, 3 minus I, and 4 plus 8i as a 1 by 4 matrix. And I get that right there. So Oh, because because I use the semicolons, it became a columns. But commas would be rows, and so you can store entire arrays of those. And we'll do some more of that. All right, so let's hurry up and get these finished up so we can get you to an exercise. The real imaginary, you can do a conjugate. Those are just built-in commands to work on complex numbers. It's all right there for you. Boolean is a true-false. Many of you have been exposed probably through programming languages for that. And the Boolean that the point I wanted to note is a little bit about how it displays it back to you. And you have to remember, so it echoes it back to you as a 1 or a 0. It's a number, you can use it as a number, but the code actually remembers also if it was of type Boolean or not. Let me show you what I mean by that. Let's say that I have A equals 1, and I have B equals true. I'm going to leave the semicolon off because when I type B equals true, it echoes back as B is 1. So I can do things like say is bool A. Now remember A, I just put in a number 1, so it's not really a Boolean. So it sums back and says it's not. Or I can do is checking to see if B is a Boolean. Remember, I actually set that, even though it echoed it back as a 1, I did set it as a Boolean, so it remembered that. But I can just the same still do treat B as a number. So the Booleans are held as a Boolean, but they're displayed and they can operate like a regular number, a 0 or a 1. And that comes in handy if you do something like, you're going to do a multiplier that you only want to have happen if it's true. So I could say something like 800 times is bool of B. Well, it's a Boolean, so it multiplied it out. There's things you can do like that. So the Booleans, true and false, you can have a whole matrix of those again. So I might have true, true, and store them in that kind of way. So, all right, now you get into the heart of everything here, which is being held as a matrix. So a matrix is a data entity that holds n rows by m columns of doubles, Booleans, or character type data, and that can also include the complex form of doubles. If n equals m, then it is a square matrix, and there are actually there's a lot of things in nature that tie back to square matrices, things like vibrations and eigenmodes and things like that, and linear algebra that you can do on square matrices. And this actually is an older command. I got to take that out of the training because we now do support, to some extent, multi-dimensional matrices. So when you store a matrix, if it's a special case where it is just one row, that's called a row vector, or if it's one column, it's called a column vector, just for a nickname because it's so often used. So that would be something like where you're seeing me do the length, where it's let's say A equals 1, 4, 3, 5. That's a row vector, right? If I do a size of A, I should see a 1 by 4. And if I was to do the 1, and that's where I did that earlier, a little bit on accident, give the semicolon A, now I have my 4 by 1. A is now a column vector. So different things you can do to specify matrix and then to actually pull data back out of it. So I can go 2, 1, 1. So it's these matrices are set up through the square brackets, and a semicolon tells it to go over and start a new row. So I could say 1, 3, 4, semicolon 2, 4, 5. And that, oops, is a 2 by 3 matrix. I can go and let's make one a little bit bigger than that. Maybe I'll do 1, 3, 4, 2, 2, 4, 5, 1, and do one more row of 3, 8, 9, 7, 9. I got a nice 3 by 4. Now you can extract data back out in various ways. I can cherry pick just coordinates, like row 2, column 3, that should be 5. I can go and say I want all of row, I want all of column 3. So you see a 4, 5, 9. Let me clear that out so it isn't confusing. Let me do that one more time. Let's look at A. And now I can use the colon in retrieving the data as like a blank variable or all. So I might say I want all the rows of column 2. Should be 3, 4, 8. I can say I want all of the columns in row 3. So that's going to be 3, 8, 9, 7. And then I should be able to just do total blank one, which is the whole matrix. It's kind of silly, but you can do that. I can do a range. Okay, back here, let me bring this up a little bit. Okay, bring that up. I can do a range. I can say I want a rows 1 to 2 and columns 3 and 4. So I can extract bits out of the full matrix like that. Or I can just say I want rows of 1 to 2 for all the columns. All right, so you can go in and cherry pick any way that you want to cherry pick. And of course, inside of these, you've been seeing me type numbers hard-coded, but you can even do math in here. So let's say, for example, let's go back to A of 3. What's A33 is 9. That's this guy right here. So I can actually say, well, what is A 2 plus 1? Should be able to do this, and 4 minus 1. So notice I'm like doing math inside of the notation for the coordinates of the vector. No problem. And of course, those could be variables. If you really want to go there, right? I can say n equals 4. I can go up here and make n minus 1. So you can embed math all over the place inside of these type things. So that's just brief intro to matrices. And this is an example where if you had a sparse matrix that you wanted to create, you can just specify some of the data and it will pad the rest. So if we go back here, clear, let's clear all, start clean. Now I'll say A equals, actually I'll say A3, 4 equals 2. And it's going to, it says, well, in order to get a 3, 4, I got to put a bunch of zeros in. And now, okay, now I'll put in 2 at the coordinates of row 3, column 4. So that's a little shortcut way to create some sparse matrix. Of course, once you create that, there's nothing stopping me from continuing to populate it, right? Maybe I want to say 2, 2 is equal to n, which I didn't set yet, so I'll just put 7, and you can build up the matrix from there. There's a lot of other features you'll see in a future chapter of commands to create, matrix of zeros. We already did this. This is the range, where you can use hard-coded values or numerical. You can reference variables. I kind of did that. I did it in a math context, but you can just put that in there direct. Okay, so to finish up the last couple, beyond matrices, there is this cool thing called a cell. And a cell is like a matrix in concept, but each data member can be a different thing. So I'm going to go over here, and I'm going to say I want this to be a cell, and I'm going to set it. And this is an interesting thing. When you saw me doing regular traditional matrices, you saw me using square brackets. Cells use these curly braces, and inside the curly braces, I can set up the members of the cell. So I might want the first one to be a Boolean, the second one to be a matrix, the third one to be a whatever, string, right? Fourth one can be even, oh no, you can't embed cells in cells. Maybe a numerical value. So now I got this thing that is a cell, and so in A11, I now have a Boolean, and A12, I now have a matrix, which itself then has its own children, the 4 entries to that. A3 is going to be this hello, So the cell allows you to basically store data where you got a lot of mixed type that you want to store. And it comes in handy in several places that we'll see later. So for now, just remember that there's this cell entity. It's denoted by the curly braces. Its members can be any of the regular types of entities. All right, and this is what I just showed there. You can, that's exactly what I just did. And then the final one is a structure, which is kind of like a poor man's object-oriented, but very powerful, because you can create these name-value pairs. So if I say, let's clear all again, just use our A here. So if I say A is a struct, now what I can do is I can assign name-value children to that. I can say A BB equals dog, string basically. A.cc equals 5. Again, the name value pairs can mix, kind of like cells, but it has a special capability that a cell can't. I'll show that in a second. I'll say ADD equals, whatever, 1, 2, 3, 4. Okay, so if I look at A, it's going to spit out, it's a structure, and the name value pair, the name BB goes with dog, the name CC. Remember, a cell was index oriented. There was no name that went with those entries. A structure is name value pair, so each entry has a name that goes with it. If I want to draw that back out, I can just say what's ACC is 5, or what's A.BB is dog. So the name value pair, you can think of it as storing data in a structured form, which is why they call it struct. But here's the neat thing. This can be recursive, which means if I want to, I can go in and add a name value pair where that child itself is a structure. So now I got this EE data member. It's a structure, and now it can have children. So maybe A.EE. AA equals whatever 4, 5, 3, 5, 6, 7, and A.EE.BB. I can do anything I want. ZZ equals 6. All right. So what you're seeing now, if I go all the way back and type A, is it's a structure, which means it's going to have name value pairs. So the name BB has a string associated with it, dog. CC's got one value. DD is a matrix. EE is itself a structure, and its children are a matrix and a number. See, and you can go as crazy deep as you want. You can go as crazy broad as you want. So it becomes a way to store various data in a nice object-oriented hierarchical way. It's not true object-oriented with definitions and deriving classes. It's not that level, but it's kind of a real nice approach towards that. So a struct is the highest level data structure, data member basically. The struct data structure can contain any other data as a child, including other struct data structures. Data members of a struct are accessed through their associated field names, hence the name value pair, using that dot operator. And you saw me do that live. So this is just some screenshots showing the same thing that I just showed below. You can have different levels. You can have structures under a structure. You can have a cell as one of the members of a structure. And then, of course, under the cell, you can have an array of different entity types. So these are all having to do with storing data. Everything I've covered since the system commands is how you store data. Here's an example of the whole structure that has lots of different name value pairs with it, page 46. To finish up, a couple things on operators, and we'll turn it over to the exercise. Operators are commands which allow you to take action with more than one data member. Most are applicable to multiple kinds of data types. So this section will focus on introducing each main operator and showing a simple and more involved example of each. Most of this is what we all know every day from our calculators, with the exception of the dot. And that's the one I want to draw attention to. If since we're dealing in the world of matrices, and there is something out there called linear algebra, which is where you actually do multiplications and things of matrices, there's the times where you want the matrix to act as a matrix, and there's times where you actually want to have the operation repeated on each member of a matrix or an array. So let me show you what I mean there. So let's say that I have this handy little matrix, 1, 4, 7, 9, 8. It's a 1-by matrix. And now there's a few different things you can do with that. If I say A times A, in fact, this one, the dimensions, it's not going to like that. Let me think of one. Let's say if I do an A squared. Yeah. Hang on a second. You do a square one here. It's better to show this with so that it works with those. So 1, 4, 2, 5. So I'll make a square matrix. Now it'll work. So if I say what's A times A, that's a legitimate matrix calculation request that you would learn in linear algebra. But suppose that what I really want to do is I want to do the same operation. I want to multiply A times itself, where I want the first member to just multiply itself by the other first member, and the second member to multiply by the second member, and the third by the third, and the fourth by the fourth. And that's where the dot comes in. If I say A dot star A, notice what it does. It says it's taking the first member and multiplying it, in this case, by itself. I could have had a different matrix here. And second member, third member, fourth member. Maybe you can see it clearer if I do this. If I do B equals 6, 7, 8, 9. So I got A and B. If I do A times B, that's going to do a linear algebra, matrix of A following matrix calculation times B. It's going to do the whole determinant bit and get these numbers. If I do A times B, it's going to take the first member of A, multiply it by the first member of B. Second member of A times the second. So it's really taking, and it's saying, I just want you to treat each member independently and do whatever I ask. In this case, it was multiply. I can do a divide. I can do A dot times 5 against each member. So the dot notation is basically saying perform the requested operation member by member. Without the dot, it's going to follow linear algebra to the best of its ability. That's the main message that you want to get from that. And you can do typical operators. Well, now what I like to do in this training is each chapter ends with a list of additional commands, which we clearly don't have time to talk through every command. It would be a very long class. So commands or other aspects which apply to the same category that was covered in the chapter, we'd like to just list those out, and then you can go look them up later. It's kind of a way to give a visual categorization to those. So we're right smack on time. We're going to go into 2A, and I'm going to give you the full 15 minutes here on this. 2A starts on page 19, and it's basically getting some hands-on for many of the things that we just talked about here. And as before, I will, after a quick water refill, I will be online for questions, and I will stay here and we'll close at 5:30. And by all means, if you haven't finished by then, since it's fresh, go ahead and take a few more minutes to close out. So I'll be back in 30 seconds and dig into exercise 19, where you basically are going to get to have a little hands-on for all those same concepts that we just talked about here. I'll see you shortly.
Yeah, just like last time, I will stop the recording, so there's no dead space there. But if someone does have a question, I'll turn it on when John answers.